Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the Algebra 2 Common Core Regents exam for spring 2015. All right, let's take a look at question number 1. It reads, if A, B, and C are all positive real numbers, which graph could represent the sketch of the graph P of x equals negative A times x plus b times the quantity x squared minus 2cx plus c squared. Now, one tip for problems like this is that the x-intercepts, the points where the graph cuts the x-axis, are the same as the roots of the related polynomial, okay? For this problem, these are the steps we're going to follow here. First of all, we're going to find the roots of this polynomial right here. And then we're going to use the orientation of the parent curve of cubic functions to determine what the final answer is. The nice thing about this problem is that finding only one root, the easier to find, is sufficient to help us narrow down our options to such a level where the orientation of the parent curve can tell us what the answer is. Okay, so I'll go ahead and now solve it using one root, and then I will show you how to find the second root just for enrichment purposes. Okay, all right, so step 1, we want to find a root of the polynomial. All right, so how do we find the roots? So let's put that, find roots. What you do is you set the polynomial equal to 0, okay? So you have negative a times x plus b times the quantity x squared minus 2cx plus c squared. Set it equal to 0. Now, what does this mean? When you set a polynomial equal to 0, you're looking for the x-intercepts. Remember, the x-intercepts are the roots. Now, we have this a here. A is a real number, positive real number. So to simplify the situation, we can divide both sides of our equation by a. Or just to make things easy, we can divide by negative a. Okay? So what happens when we divide both sides of our equation by negative a? We're left with the quantity x plus b times x squared minus 2cx plus c squared equals 0. All right, so we can solve for two roots. First one, we can set x plus b equal to 0. Or we have x squared minus 2cx plus c squared equals 0, using the zero product property. Now, which of these is easier to solve for x? We can clearly see the first one, okay? So to solve for x here, we'll subtract b from both sides, and we have x equals negative b. So what does this tell us? It tells us that this graph has to intercept the x-axis at negative b. So where does that happen? It happens in option 1 and option 3. If you see the graph cuts the x-axis at negative b here and here, doesn't happen here. So we'll eliminate option 2 and option 4. Now, what is going to help us finish this problem is the orientation of the parent curve. This is a cubic. It belongs to the cubic family. Now, how do I know that this belongs to the cubic family? I know it belongs to the cubic family because if you expand it, the highest degree is going to be a cube. Okay, how do we know that? Well, consider this. You have negative x plus b times x squared minus 2cx plus c squared. Now, all you have to do is multiply the highest degrees of x in each quantity, okay? So this is x to the first power, this is x squared. If you multiply them together, that tells you the degree of your polynomial, which is a third degree, okay? Now, if you notice, in this polynomial, the sign is negative, okay? So let me show you the two orientations for the cubic family. So for the cubic family, It either goes from negative infinity to infinity or infinity to negative infinity. So if you have this orientation, something like this, right? This is y equals positive x to the third. Okay, this is when you have a positive in front of the x squared. If you have this orientation, something like this, in this case you have y equals negative x to the third. Okay, so which of these is applicable to this problem? We're looking at this orientation, the negative cubic family. So the negative cubic family starts from infinity and goes to negative infinity. So let's take a look at these two options we have here. Which of these two orientations matches this one right here, from infinity to negative infinity? We can clearly see that our answer is option number 1, going from infinity to negative infinity. This is a negative cubic. Okay, you can go ahead and skip ahead to number 2, but I'm still going to just give you some more information on this problem. Even though you already know the answer, I want to give you some enrichment just to show you some cool facts about this problem that could be helpful in other problems, okay? All right, now consider this situation. What if I wanted to solve this equation right here for the roots? Is it possible for me to do that? X squared minus 2cx plus c squared equals 0. Can I solve this for the roots? The answer is yes. Okay? If you're familiar with your expanded states, you will see that this actually is a square of the sum of a binomial. Okay? But let's assume that we don't know that, so we're just going to go ahead and factor this. Okay? So you go ahead and make your x game. So in this polynomial, this really looks complicated. We need a, b, and c, so we can factor using the AC method. For this polynomial, the coefficient of x squared is a, so that's 1, and then we have negative 2c and c squared for c. So a is, well, let's use lowercase. So a is 1. B is negative 2c, and c is c squared. Okay, so AC goes on top, AC is c squared, B goes on the bottom, negative 2c. Now we're going to ask ourselves, what's two numbers multiply to give you c squared and add to give you negative 2c? The answer is negative c and negative c. Let's do a check. Negative c times negative c is c squared, and negative c minus c is negative 2c. Perfect. Now, since a is 1, we can skip to the factored state. We don't have to factor by grouping. We can skip to x minus c right here times x minus c right here equals 0. So that's a factored form of this polynomial. Okay, so if we have this, we can go ahead and use the zero product property. With the factored state, x minus c equals 0. X minus c times x minus c equals 0. We'll simply set both factors to 0 and solve. You're going to get x equals c. So what does this tell me? It tells me that the graph has to intersect the x-axis at c also. Another thing you want to note is that you had c twice, right? So what does that tell us? It tells us that we have something called a double root. What does a double root mean? A double root means that you have the vertex of a polynomial residing exactly at the x-intercept at that point. So if you take a look at the two options we narrowed down to earlier, you notice that we have the vertex right here on C. This is a double root. Okay? This is very cool to know about. And now here also you have a double root. Okay, you have a double root, and there you have a double root. Okay, so that's just some information. But we can clearly see that the answer we got is consistent with option number 1, the answer we knew before. All right, let's take a look at problem number 2. It reads, The equation represents a parabola with a focus of 0, 4 and a directrix of y equals 2. Now, one quick tip you want to keep in mind for parabolas is that a parabola always opens in the direction of the unsquared variable. Okay, so if you have y equals x squared, what does that tell us? Well, let me write that down real quick. Let's say I have y equals x squared. Which variable is unsquared here? It's y. That means the parabola is going to be opening up or down. Since y is positive, it's going to be opening up. Now, what if I have x equals y squared? Well, since the x variable is unsquared, the parabola is going to open in that direction. Since it's positive, guess what? It opens to the right. Okay? So remember, parabola goes in the direction of the unsquared variable. Okay, these are the steps we're going to use to solve this problem. Step number 1 is very, very important. Sketch, sketch, sketch. Okay? If you're dealing with conic sections, circles, ellipses, hyperbolas, parabolas, do not try to do things mentally or abstractly. Give yourself a solid visual so you do not confuse your variable values. Okay, so sketch the parabola using this information. Number 2, we're going to write down the vertex equation for the parabola based on the orientation of the parabola. There are 4 possible orientations, so we have to make sure we have the write down the correct equation. And then we'll solve the resulting equation for y. If you notice, the options we have here are all solved explicitly for y, so we have to do that. Okay, let's go ahead and draw our parabola. So another thing you want to note, well, let's draw this information first before I talk about that. So there goes my y-axis, and there goes the x-axis. The focus is 0, 4, 1, 2, 3, 4. There goes your focus. And then the directrix is y equals 2. Remember, y is a horizontal line, whereas x is vertical. Don't forget, y is horizontal, x is vertical. Okay? So y equals 2 is our directrix. Now, one thing you want to note, I was going to state this earlier, is that the parabola always goes in the direction of the focus. The vertex is always at the center, the midpoint between the directrix and the focus. So this line right here is your directrix. And this point right here, that's your focus. Okay? And what's in between 2 and 4? 3, right? So your parabola is going to look something like this. Okay, I'm just exaggerating the width. So it's going to look something like this. Okay, now, what's the benefit of, drawing all this? Well, it helps us to find some important pieces of information. To help us determine what they are, let's go ahead and write down the vertex equation of the parabola first. So let's see. There are 2 options we have here. Okay, we have x minus h quantity square equals 4py minus k, or we have y minus k quantity square equals 4p x minus h. The difference is that in the first one, x is squared, and the second one, y is squared. So which one do you think is applicable to this parabola right here? We talked about this in the tip. The parabola always opens in the direction of the unsquared variable. Okay? Since the parabola opens in the y direction, in the direction of the y-axis, what does that tell us? It tells us that we want to pick the one where y is unsquared, where y is not squared. Since y is squared in the second one, scratch that. This is the one we are going to use. That's the formula. Okay? So students often get confused, wondering, which formula do I pick? Let the orientation of the opening of the parabola help you determine the correct choice. Okay? All right, so that's the formula we're going to be using. So what does this formula tell us? It tells us that we need four things. I'm sorry, we need three things to write down the equation. Okay, what are they? Well, let me write this again. X minus h quantity square equals 4p times y minus k quantity closed. Okay, so can you see the things we need? The three things we need. They are color-coded for you. We need hk and p. If we can determine hk and p from the graph, then we're good to go. All right, so let's start with hk. What is hk on the graph? Hk is the focus, okay? So the focus, hk, is equal to, what's the focus in this problem? The focus is 0, 4. So this tells me that h is 0 and k is 4. Nice, we have 2 down. The last thing we need to do is p. We need to find p. What on earth is p? Well, p is the distance between the vertex and the directrix, or the vertex and the focus. Okay? Where is the vertex on this graph? This is the vertex right here. Okay, so there goes your vertex. So the question is, how far is the vertex from the focus, or how far is the vertex from the directrix? It should be exactly the same measure because the vertex is at the midpoint of the focus and the directrix. Okay, so we need h, k, and p. All right, so our vertex, the vertex is hk. All right, so what is the coordinates of the vertex here? This is 1, 2, 3. So the vertex, the coordinate of the vertex is 0 for the x-axis and 3 for the y-axis, 0, 3. So our vertex hk is 0, 3. Okay, now what is p? P is the distance from the distance from the vertex to the focus, or the distance from the vertex to the directrix. They should be exactly the same measure, namely 1. Okay, so p is 1 unit long. That's all the information we need to generate the equation of our parabola. So we have x minus h, which is 0, square equals 4. P is 1 times y minus k, which is 3. All right, so we're just going to get y by itself in this equation, and that will be that. So if you square this right here, x minus 0 is just x, so we have x squared equals 4y minus 12. Okay, and then we'll go ahead and add 12 to both sides. So we have 4y equals x squared plus 12, and then divide both sides by 4. And that gives us the answer, which is y equals x squared over 4 plus 3. X squared over 4 plus 3. Option number 4 is your correct answer here. All right, let's take a look at problem number 3. It reads, if the terminal side of angle theta in standard position passes through points -4, 3, what is the numerical value of sine theta? Now, one tip you want to keep in mind is when you're using the Pythagorean theorem, the hypotenuse is always c, and the two sides, known as the legs, are a and b in any order. It doesn't matter, okay? All right, so the steps for this problem are as follows. First of all, we're going to sketch. Do not forget to do that. Anytime description is being given of some abstract shape, you want to give yourself a concrete visual. So we're going to sketch the angle in standard position, label with reference to the angle theta. We're then going to find the missing side using the Pythagorean theorem, and then use SOHCAHTOA to set up our ratio. So let's go ahead and sketch -4, 3 in standard position. That's not difficult. There's basic point graphing. Negative 4, 3 is going to be in quadrant number 2, 1, 2, negative 4, 3, 1, 2, 3. There goes theta in standard position. All right. So if you want to graph theta in standard position, theta is going to be the measure of the angle from the terminal side to the closest x-axis. So this is theta. All right. So let's draw this right here. What do we have? We have a right triangle. Okay, this is 3, this is negative 4. Now, we want to find sine theta. All right. In order to use sine theta, to find sine theta, we're going to have to use SOHCAHTOA. What SOHCAHTOA depends on the labels on the sides of a triangle: opposite, hypotenuse, and adjacent. So what is the opposite here? What is the hypotenuse, the adjacent? The side opposite the opposite theta is always your opposite. So that's opposite, O in SOHCAHTOA. The longest side opposite 90 degrees is always your hypotenuse. Okay, so there goes your hypotenuse there, H in SOHCAHTOA, and the other side is your adjacent. Now we need sine theta. So what does this tell us? Sine theta tells us, tells us that sine theta is opposite over hypotenuse, right? So what is your opposite? Opposite is 3. Nice. What is our hypotenuse? Uh-oh, we don't know what it is. We're going to find it. All right, so how do we find it? Now, what we have here is a right triangle where we have one missing side. Anytime you have to solve a right triangle with a missing side, you can always use the Pythagorean theorem. Okay, so we're going to take a detour here and we're going to find hypotenuse. All right. How do we do that? We're going to use the Pythagorean theorem. So remember we talked about this earlier. A and B are the legs. It doesn't matter what you call A and B, but C is always your hypotenuse. So C is your hypotenuse. So I'm using the Pythagorean theorem. We have A squared plus B squared equals C squared. Now, those of you who know your Pythagorean triples, what do you think C is equal to? C is 5 because you have 3, 4, 5. That's a Pythagorean triple. So let's assume you don't know that. Let's go ahead and solve for it algebraically. A squared is going to be negative 4 squared. Remember to encapsulate the negative value. Negative sign of 4 in the parentheses. That's important. 3 squared equals C squared. If you expand this, you have C squared equals 16 plus 9. C squared equals 25. We get C by itself. C is equal to 5. Now we have the hypotenuse. All right, so H is 5. So what is sine theta? Sine theta is opposite of a hypotenuse. Opposite is 3. Hypotenuse is 5. So our answer is option number 1. All right, let's take a look at problem number 4. It reads, a study of the annual population of the red-winged blackbird in Fort Mill, South Carolina, shows the population B of t can be represented by the function B of t equals 750 times 1.16 to the t, where t represents the number of years since the study began. In terms of the monthly rate of growth, the population of the red-winged blackbirds can be best approximated by the function. So one thing you want to note in this problem is that if you want to express an annual growth rate model as a monthly growth rate, in monthly growth rate terms, you're not changing the growth model, okay? You're just changing the way it looks. So if this is an annual growth, when you change it to monthly growth terms, it doesn't mean that the growth rate is being compounded monthly, okay? So someone can easily confuse this problem as converting an annual growth into a monthly compounded growth situation and get the problem wrong. That's not what this problem is asking for. Okay? All right, so what are we going to do here? We're going to express the power as a multiple of 12. That is the ultimate goal using the appropriate algebraic processes, and then we're going to adjust the 1 plus r in the parentheses, 1 plus the growth rate accordingly. Okay? All right, so let's go ahead and do that. So originally, expressing it in terms of annual growth, we have b of t equals 750 times 1.16 to the t. Now, if we want to express it in terms of in a monthly growth rate terms, we are just going to do this. Check this out. This is really cool. You have 750 times 1.16 raised to the 12 over 12. Now, what is 12 over 12? 12 over 12 is 1. So I didn't change the problem. I just introduced 1. Okay? So what I'm going to do is I'm going to separate the power into numerator and denominator. So I'm going to have 750 times 1.16. I'm going to take the denominator and put it right here. And then I'm going to put the numerator outside with the t. Okay? This is the reverse of the product of powers property of exponents. Okay? I'm sorry, the power of a power. So whenever you have the power of a power property of exponents, you multiply the powers, so you can also separate them into factors. So this is the same as that, because when I raise this to that power, I will multiply 1 over 12 by 12t. So that gives me 12t over 12, which reduces to t. So these are exactly the same thing, okay? Now the last step is just simply evaluate the value of 1.16 to the 1/12th power, and we should be done. All right, I'm going to use the TI-83 plus for this computation. So we have 1.16 raised to the 1/12th power. Now please encapsulate your power in parentheses, or else this could result in a grouping error, okay? So notice how I grouped my 1 over 12 in parentheses. Enter 1.012, okay? So remember, we are not changing the model. We're just altering its appearance and expressing it in terms of months, okay? So we've got to be careful with that. So this becomes 750 times 1.012 raised to the 12t. Okay, so our answer is option number 2. All right, let's take a look at that problem number 5. It reads, use the properties of rational exponents to determine the value of y for the equation the cube root of x to the 8 over x to the 4th raised to the 1/3 power equals x to the y. All right, so one tip for this problem is that whenever you're applying the properties of exponents, you always want to express all terms as exponents first. So you want some kind of consistency across all terms. You don't want to be working with exponents and radicals, rational exponents and radicals. That's not good. You want to write everything as rational exponents first, and then go on from there. Okay. All right. So steps. We're going to express both the numerator and the denominator on the left side as rational exponents. And then we are going to apply the appropriate property, namely the quotient property of exponents here, to simplify it. And then lastly, upon simplifying the left side, we're going to see what the value of y is. What is the power of x on the left side? That is what y is going to be equal to. Okay? All right, so let's go ahead and get started. Step 1, I want to express this radical right here as an exponent. So let me write down the rule for you. If you have, let's say, the nth root of a to the m, this is equal to a to the m. Guess what? This root becomes the denominator of your rational exponents, a to the m over n. Okay. All right, and on the bottom here, I'm going to be using the power of a power property of exponents. We kind of used that, a version of that in the previous problem. So if I have a to the m raised to the n power, this becomes a to the n times n. This tells me that if you have an exponent raised to a power, simply multiply powers. Okay? All right, so let's apply these two rules to these two expressions. On the top, we have x to the power 8. The root becomes the denominator. Okay? Over, using the power of power property of exponents, 4 over 1. 4 over 1 times 1/3 gives us x to the 4/3. Okay? Now, we're going to use one more property, the quotient property of exponents. If you have a to the m over a to the n, the quotient of two exponents with the same base, that can be condensed into the exponent raised to the difference of the powers. Okay? So whenever you're dividing exponents with the same base, you simply subtract the powers. That's what we are going to do here. So this becomes x to the 8/3 minus 4/3. Okay? And let's not forget the right side of the equation equals x to the y. Okay? All right, let's simplify it and see what y is equivalent to. So if you subtract this, this is nice because the denominators are the same. X to the 4/3 equals x to the y. What does this tell us? The powers have to be equal. Since the bases are equal, 4/3 equals y. So that is the value of y. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We'll really appreciate your positive feedback. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about this tutorial or any questions on the Algebra 2 Common Core Regents exam, just place a comment to the comment section below and we'll be glad to address it as soon as possible. Also, don't forget to practice your skills at our interactive practice test that can be accessed by clicking on this link. More clips can be found on math.serve.com. Thanks again for watching.